El Niño. It's a term we hear thrown around in weather forecasts all the time, right? But the sheer scale of this phenomenon is just staggering. It is a massive global disruptor. In fact, within just a 2-decade span, this incredible force of nature triggered 2 separate anomalies that were each literally dubbed the event of the century. The first one completely changed how societies respond to natural hazards, and the second one fundamentally flipped our scientific understanding of global climate change.
So, let's look at our roadmap for this explainer. We've got 5 quick parts today. 1. Spawner of hazards. 2. Once burned, twice shy. 3. The global warming hiatus. 4. Solving the climate mystery. And finally, 5. Fixing the leaky roof.
All right, part 1, spawners of hazards, defining the threat.
Before we get into the really wild stuff, let's make sure we're all on the same page. The overarching system here is known as ENSO. That's the El Niño-Southern Oscillation. Think of it as a giant planetary seesaw of pressure and temperature out in the Pacific Ocean. Keep in mind, El Niño specifically refers to the warm phase of this cycle. When that enormous pool of warm water shifts away from the west and moves toward the central and eastern equatorial Pacific, it completely scrambles weather systems all over the globe. It's a true spawner of hazards. We're talking droughts, floods, massive fires, and even disease outbreaks worldwide.
And that brings us to the 1997-1998 event. This thing was so intense, so devastating, that scientists and the media started calling it the El Niño of the century. It served as this massive global wake-up call to governments and industries. Suddenly, there was no denying it. Warming waters thousands of miles away in the tropical Pacific could, and absolutely would, devastate local economies and environments.
Moving right along to part 2. Once burned, twice shy, the societal wake-up call.
So society got its massive wake-up call. But that leads us to a fascinating and honestly kind of sobering assessment by the UN Environment Program. They wanted to know if we actually learn from these devastating anomalies once they happen. The researchers looked across 16 different countries, from Bangladesh to Costa Rica, Kenya to Peru. And their central question was surprisingly simple. If we are once burned by a disaster, are we actually twice shy the next time? Like, if scientists give us a perfectly accurate forecast months in advance, will governments actually do anything to mitigate the damage?
Well, looking at this staggering list of systemic failures, the answer is a complicated no. This brilliantly illustrates why, even when the scientific warnings are flashing bright red, the actual societal response falls incredibly short. The wild part? The obstacles weren't usually about the science itself. Instead, they found agencies fighting over jurisdiction. They found political and economic crises totally distracting the leadership. You've got a lack of basic mitigative resources, terrible communication with the public, and massive lag times between getting a forecast and actually acting on it. The playbook on how to prepare is out there, but the execution is just missing.
Which brings us to part 3, the global warming hiatus, a scientific mystery.
So while societies were busy fumbling their policy responses into the 2000s, scientists were suddenly hit with their own massive problem. It was a gripping geophysical whodunit. Right around the early 2000s, global mean surface temperatures just seemed to slow down. They paused, but human carbon emissions were steadily climbing the whole time. This whole thing was dubbed the global warming hiatus, and it completely baffled the scientific community. It sparked intense debate. Like, where exactly was the heat going? The oceans? Aerosols? Some skeptics even tried to use it to argue that global warming had stopped entirely. No way, right? But they had to prove it.
That takes us to part 4, solving the climate mystery, the 2015-16 extreme.
The key to finally unraveling this hiatus mystery arrived with the next extreme climate anomaly. Because just as the '97 event tested society, the massive 2015-2016 El Niño was going to test our science. Researchers at NAIL decided to build a physically based mathematical model, but instead of overcomplicating it, they basically stripped away all the background noise. They realized you really only need 3 primary drivers to track historical global temperatures. Number 1, greenhouse gas emissions, mostly CO2. Number 2, ENSO atmospheric heating. And number 3, the cooling effect of stratospheric sulfate aerosols, the stuff pumped out by major volcanic eruptions. And the data they found is amazing. By analyzing high-resolution satellite observations from the tropical Pacific, they discovered something incredible. Even though the equatorial Pacific takes up less than 3% of the globe, ENSO literally acts as the thermostat for the interannual heating rate of the entire tropical atmosphere. The correlation is just off the charts. During a strong El Niño, immense amounts of ocean heat are basically vented into the atmosphere, causing global temperatures to suddenly spike. Now check this out. This is the big reveal. When researchers ran their model using just those 3 drivers, it flawlessly reproduced global temperatures going all the way back to the 1880s. Notice how the black model line tracks the red observation line? It's practically glued to it. It catches the overall warming trend, the sudden dips from volcanoes, and crucially, it perfectly maps the 2000s hiatus and that explosive temperature rise that happened right after.
But they didn't stop there. To really double-check their work, they ran the model again, but this time they essentially hit mute on the ENSO data. They took El Niño completely out of the equation. Look at what happens to the black line now. It completely fails to predict the 2000s hiatus, and it totally misses the rapid temperature spike of 2015. Without El Niño, the hiatus simply does not exist in the model.
So the crucial point we have to take away here is that El Niño acts as a global pacemaker. That whole global warming hiatus in the early 2000s, it was literally just the result of weak El Niño activity masking the continuous underlying rise in CO2 temperatures. And when that massive prolonged 2014 to 2016 El Niño finally hit, it released years of stored-up ocean heat into the atmosphere and definitively ended the warming pause, making 2014, 2015, and 2016 the hottest years on record. Mystery solved.
And finally, Part 5. Fixing the leaky roof. Preparedness meets science.
Let's bring everything together now. We've got the predictive science, we know our historical failures, so what do? I absolutely love this analogy from Michael Glantz, the lead investigator of that UN report. He says, the time the farmer should fix his leaky roof is when it is not raining. It hits the nail on the head. We know these anomalies are going to return every 2 to 10 years. It's a guarantee. We have to use the normal periods, the quiet times between the extremes, to cut through the bureaucratic red tape, fix our communication lines, and build true, lasting societal resilience. As we wrap up this explainer, I want to leave you with this thought. Thanks to the wild extremes of the past 2 decades, we now possess incredibly accurate climate models. We've learned the hard, painful lessons of past societal failures. We finally understand the immense mechanics of El Niño and its role as the pacemaker of global warming. So, the multi-trillion-dollar question is, when the equatorial waters inevitably warm up again, will society finally be ready, or are we just going to get burned twice? Definitely something to keep in mind the next time you see sea surface temperatures rising on the news. Thanks for joining me on this deep dive into the data.